everyone, I'm Kathy Zip, Managing Editor of Solar Power World, and I'd like to welcome you to today's webinar, Air Filter Solutions for Solar Power Equipment. Before we begin, we'll go over just a few house cleaning items. I'd like to mention that this webinar will be available after the presentation on solarpowerworldonline.com, and also will be emailed to all registrants, so you'll be able to view it again at your convenience. Secondly, there'll be a question and answer session at the end of all the presentations. This is a great way to pick our presenters' brains, so we encourage you to participate. You can do so by submitting your questions whenever they come to mind at any time, just by typing them into the GoToMeeting panel on your right. Lastly, we encourage everyone to tweet about key topics and discuss takeaways using the Twitter hashtag #SolarWebinar. And at this time, I'd like to introduce our presenter. Today, we're thrilled to have Dan Kroop, Director of Sales and Engineering at Universal Air Filter. So we'd like to extend our thanks to Dan for being with us today. Dan has been involved in the filtration business for longer than he'll admit. A well-versed engineer by training, Dan manages a team of technical account managers, developing and supporting new business relationships. This includes helping customers satisfy their most demanding filtration requirements. Dan has expertise and responsibility for strategic planning, international technical sales, design engineering, research and development, and product management. So again, we're very excited to have him with us today to share his expertise. And Dan, you can go ahead whenever you're ready.
Thank you, Kathy, and welcome to the Solar Power Air Filter presentation, and thanks to all who've taken time out to participate today. The plan is to keep the information flowing quickly, and it's not all about air filters. But air filters do get dirty, and as you might guess, the subject matter is sometimes less than clean, so you want to keep focused. Please turn off your email, put your smartphone in airplane mode, and get ready for the filter guy to talk dirty to you. Just a quick rundown of the content to be presented today. We can expose you to the types of power gen devices that employ air filters in solar power systems and make you aware of how they can help protect equipment in an effort to avoid loss of energy production. The system design section will list applicable industry standards in thermal management and airflow restriction considerations. That'll be followed by a step-by-step specification process for our next generation design and retrofit applications, including innovations used to make the most of cooling air resources. And finally, we'll introduce other innovations in addition to filtration that enhance equipment protection. So what kinds of devices employ air filters, and where are they located in power gen systems? Here's a simple example of a Schneider PV inverter that uses a couple different size pre-filters behind the intake vents at the lower portion of the doors. There's also high efficiency filters installed inside the racks. Now, SATCON is no longer in business, but their inverters are very actively deployed in solar systems all over the world. Some of these Equinox and Solstice units include as many as 11 different air filters in each unit. Power One Aurora inverters are used in both solar and wind power systems. Of course, Eaton makes power gen equipment with air filters included as well. And it's not just inverters, but other large components like DVAR, dynamic volt amp reaction solutions, and other transformer rectifier systems use air filters. Enclosure and shelter doors sometimes have air intake filters, and equipment housed inside the shelters have filters in their cabinets as well. Many times the OEM supplied door filters are inadequate and need to be beefed up and retrofitted to provide better contamination control and serviceability. When enclosure door filters fail, it's not good for sophisticated equipment housed within. When the doors fail, unfiltered air enters the enclosure. This will impact smaller cabinet intake filters, electrical panels overheat, and energy production fails. Not good at all. For general reference, it should be noted that in addition to solar systems, you will also find electronics, electrical equipment equipped with air filters in telco networks and in wind power systems as well. Dirt, dust, moisture, corrosive salt air, and electromagnetic interference disrupt equipment performance and ultimately lead to system failure. For now, we can take a break from talking dirty and we'll switch gears to show you some dirty pictures. Filters help protect equipment and they catch dirt and dust. Harsh environments are tough on electronics and electrical components. Take a look at the photo at right showing a new, clean, green-colored air filter flanked by filthy, used filters that are in need of cleaning or replacement. Here's an intake vent on a cabinet that illustrates the types of contaminants that can enter into an enclosure as technicians enter and leave the shelter and leave the doors open. Technician in this photo is removing the intake bezel to reveal the air filter shown on the previous slide. Just pops that vent off there to get to the foam. This is the fan unit that pushes cooling air into the enclosure, and it's shown here without the filter or the intake bezel installed. This photo shows the exhaust side of the cooling fan on the right side of the picture there, and the super clean insides of the electrical cabinet that are a result of using a properly specified air filter to keep equipment running at optimum efficiency. No dirty talk here. The electrical gear inside is super clean. Still using the simple foam air filter pad as an example, these photos show the technician using plain drinking water to wash off the dirt and dust and squeezing the water out before letting it dry and reinstalling. If you need to use water to make sure filters are completely dry before you reinstall, moisture can be a real big problem with electronics and electrical systems. Washing filters is easy, and most times you can clean without the need for water. Just use a vacuum as shown, or blow out with compressed air to clean and reuse. Saves on purchasing, logistics, and storage, and the filter should last at least a few years if environments are not overly corrosive. The message with maintenance is make sure you have preventative maintenance procedures in place to check filters and clean and replace on a regular basis. Clean, cool equipment performs most reliably. Energy efficiency follows, and you can lower your energy rates by 5 to 15% by eliminating clogged filters from your systems. The most important point is to eliminate energy production failure. Now we'll switch gears again and discuss next generation equipment and OEM design considerations. Electronics and electrical enclosures in forced air cooling applications pretty much all share the same basic characteristics. What's the size? What level of components are stuffed into the enclosure? What types of fans are needed? And where's the best place to locate the fans? Industrial design is the overall look and feel of the product, including the use of appropriate colors and attractive shapes and contours on your metal and plastic enclosures. Air filters are an essential part of forced air systems, and it's best to consider them early in the design process. It's important to be aware that customers require compliance with power industry specific standards like UL 1741, as well as general enclosure ratings like NEMA and IP. These ratings indicate a degree of protection against falling rain, splashing water, and hose-directed water. Additionally, the enclosure may be required to remain undamaged by the formation of ice on the enclosure, and there are also corrosion resistance specifications as well. UL 94 and UL 900 are component plastics and air filter specific flame ratings, and are sub-requirements and referenced within the enclosure equipment standards that are shown to the left. Moving from physical enclosure designs, there's also thermal management design considerations used to dissipate harmful heat buildup in densely populated chassis. Thermal analysis software packages are used to simulate equipment thermal characteristics and calculate the effects of less restrictive and more restrictive air filter media on overall system pressure drop. Note that all physical components contained in the chassis impede airflow effectiveness to varying degrees. Air filters are no exception, but can be custom configured to match the airflow requirements of the specific application and deliver the most effective dust capturing at the lowest pressure drop. Forced air systems design use three popular cooling configurations. Fans on the intake side push cooling air through heat sources and pressurize the cabinet. As shown in the diagram at the right, fans on the exhaust end pull cooling air through and evacuate the hot air. More demanding thermal management challenges require fans on both ends to get the job done. Pros and cons of pressurized enclosures with fans pushing cooling air in. The upside is all moving air is fully dust-free, and the filter is utilized to distribute the airflow in a laminar pattern. Some of the downsides are you need to add room generally to accommodate a space between the fans and the filter to take full advantage of the complete filter surface area. Pros and cons of fans on the exhaust side drawing cooling air through the chassis include pulling air from all crevices and not just through the air filter opening. There's no need for extra enclosure space to separate the fans from the filters because they are naturally in this configuration. The downsides are because you're pulling air from all openings, some unfiltered air will make its way through, and you don't get to take advantage of air filter diffusion qualities provided by the filters. Fans on both the intake and the exhaust ends maximize cooling air and allow for more dust holding capacity. Unfortunately, you need to make room for more fans, use more power, and more fans usually means more noise. The next section here introduces some popular air filter product solutions and reviews a step-by-step process to to help with specifying a custom air filter to meet your application-specific requirements. Precision sheet metal fabrication and custom manufacturing capabilities allow equipment designers to utilize all space available to maximize cooling airflow. Rule number 1 is do not design your chassis around a standard air filter available on the shelf. Design a custom air filter to meet the specific equipment protection needs of your project. Super thin filters are available when space is limited, and filters can be integrated into the chassis designs to consolidate vendor lists, consolidate components to incorporate frames, media, intake bezels, EMI shielding, and plenums into single integrated assemblies. Add sheet metal or plastic components to air filters and lower your costs. Taking a look at some of the useful power gen filter products that are out there, all metal filters are most durable for the harsh environments experienced by power gen equipment, and they're also reusable and rugged enough to stand up to multiple cleanings. High efficiency filters are generally more expensive and not recommended for cleaning and reusing. However, sometimes equipment gets deployed in uniquely contaminated environments, and it's good to know the option is available to improve equipment protection using high efficiency air filters. Another durable product that's reusable and offers higher efficiency dust capturing is electrostatic media. Washable polypropylene mesh stands up to corrosive airborne chemicals. It's lightweight and delivers improved dust capturing over the all-metal filters. By its very nature, utility scale equipment commonly consists of high voltages and generates electromagnetic interference. You should know that openings and cabinets needed for fresh air intake can be configured with air filters that include EMI shielding. Integrated assemblies promote SKU and vendor consolidation and also save on space. EMI panels for exhaust openings with no need for dust filtration are also popular in cooling systems that run 24/7. Finally, honeycomb fireblock panels are available to allow air to flow freely in vent openings under normal operating conditions. In the event of a catastrophic equipment fire, flame-activated panels transform into fire blocks to prevent damage from spreading to other devices in the network. Check out this Pyrocide video and learn about a more robust equipment protection option. Made from an aluminum honeycomb core with a heat-responsive intumescent flame coating, Pyrocide vent panels are designed to provide fire containment within electronic enclosures. Upon the introduction of a flame, the intumescent coating expands, preventing flames from passing through the honeycomb openings and reducing flame-fueling airflow through the system. The coating expansion is generated using a flame-activated chemical reaction and will not creep or expand with less significant elevated temperatures in an enclosure. The intumescent coating withstands even the highest temperatures, as shown by eliminating flame passages from a welding torch. By preventing flame spread, Pyrocide vents reduce damage and downtime caused by a fire outbreak. This material can be used to help meet industry safety standards, including the Telcordia Nebs GR63 flame spread test. For more details, please visit uaf.com. Another equipment protection option for harsh coastal environments is outside plant OSP air filters. These are deep pleated, high efficiency OSP filters that allow fresh cooling air in and keep water and salt fog out. OSP filters are configured with washable pre-filters to keep dust particles away from waterproof membrane media. They also can include special metal finishes for corrosion protection and water seal gaskets to keep equipment 100% moisture free. To simulate hurricane-like conditions, OSP filters have endured exhaustive wind-driven rain test programs to match the telecom industry's most stringent cell site environmental standards. These stringent telecom specs also require compliance with a rain intrusion test that simulates exposure to placement near active irrigation systems. Finally, the salt fog test demonstrates reliable operation when subjected to corrosive coastal conditions. Summing up the specification process, here's your step-by-step air filter design checklist. Start with determining the standards and specification you are required to meet for your application. Understand flame safety and flame rating requirements. Select the size your air filter can be or needs to be. Pick a framed air filter assembly. Decide if you need handles or tabs or other fixture components. Select the flame retardant media, thickness and porosity or density of the media. Determine your linear airflow velocity requirements and calculate the maximum pressure drop that a filter may introduce into your system. Select media color for industrial design purposes, and add special metal finishes, and prepare your custom air filter drawing. You'll also want to pursue custom samples to test and evaluate in your equipment. When it comes to media, there are many filter media choices out there, so you need to choose the most appropriate when it comes to flame resistance, dust capturing as applicable to the cabinet size. Pick the most suitable media for the frame size you've selected. Know your airflow restriction requirements. Match equipment look and feel, and think about preferences for minimizing or maximizing dirty look for maintenance inspections. This is our final section. May sadden some of our members of the audience that we've come to the last section, but all this dirty talk is, while interesting and entertaining, it's also very exhausting, so I'm happy to report there's just a few more slides in this final section here. And what we're going to do is a quick run-through of other design factors that are useful for ensuring continued reliable energy production. Be sure to use only flame retardant plastics in your chassis, and make sure that they meet the highest UL flame safety ratings that are available. As you can see in these photos, the polymers used in these chassis are self-extinguishing and do not promote the spread of flames. Air filters also need to be UL 94 compliant to contain fire spread and keep systems reliable when subjected to catastrophic conditions. The advice here is to have an air filter maintenance plan. Do not let dirt build up on filters and cut off cooling air, as we showed in the dirty filter photos earlier in this presentation. Make sure you and your customers have access to replacement filters, and recommend cleaning or replacement every 3 to 6 months. Besides UL flame safety compliance, we also advise that you make sure your vendors are avoiding use of restricted substances in electrical and electronics hardware. Dangerous old-school chemicals like mercury, cadmium, and hexavalent chromium are strictly forbidden by the electronics industry watchdogs, so be sure your components are RoHS compliant. So when it comes to replacement power gen air filters, it helps to get full-scale samples to do fit checks and do part number checks before making a big purchase. On the other hand, physical prototypes are also mandatory for new product development projects. Make sure your replacement parts are OEM approved, UL listed, and support compliance to the UL 1741 inverter standard. Don't forget other features like EMI shielding, corrosion protection finishes, and OSP membrane filters for harsh coastal environments. A little about UAF. We work directly with thermomechanical engineers early in the product development process of next generation power gen equipment, providing design support, custom prototypes, and full standards compliance. We work with all major equipment OEMs, providing the capability to deliver OEM approved replacements for all types of equipment in power gen systems. Reviewing what we've gone over today, please consider air filters early in the design process. Understand your industry specs and your customer requirements, and analyze custom enclosure configuration for total system thermal and design management. Take advantage of the latest technological innovations and include EMI shielding capabilities if necessary. And always be sure that you, your organization, and your customers have access to OEM approved replacements. For your information, UAF is in Asia, and we've got in-country support there for new OEM project support, as well as replacement filters for existing solar systems. Same goes for Europe and the Middle East. We've got on-continent presence to support OEM and aftermarket requirements there as well. UAF, our motto is on spec, on time, every time. And we thank you for your participation in the webinar. That's all the dirty talk for today. And we're finishing a little ahead of schedule, so that should give us time to field some questions. Thank you very much.
Thank you so much, Dan. Great insight. And you're right, after all the information, our audience does have a few questions, so we will begin asking those. Remember that you can submit your questions at any time in your GoToMeeting panel on your right. So we'll start with that. Dan, you mentioned a little bit about this, but could you go over, again, how often air filters for PV inverters and other equipment should be replaced?
That's a good question, and it's a very popular question. And as an air filter manufacturer, distributor, and supplier, we react to customer behavior and preventative maintenance programs and processes. And most popularly, we are getting requests from the solar farm and solar system industry twice a year. So we'll see a spike in replacement filter delivery activity in the spring and also in the fall. Filter replacement truly is equipment specific and environment specific, but most popularly our customers in their recommendations are asking end users and maintenance teams to clean or replace filters every 3 to 6 months.
Okay, great. Can you also talk a little bit about air filter ratings? If they're rating to NEMA 3R, NEMA 4, NEMA 12, IP54?
Yes, I can. These enclosure ratings such as NEMA and IP and even the inverter standard 1741, these are end item device specifications, and they apply to the the electrical and the electronics enclosures that employ components such as air filters and EMI shielding. So the direct answer to your question is no. There are no ratings to NEMA and IP applicable directly to the air filter. Compliant air filters that are flame retardant and have performance specifications that are in line with UL standards support end customer enclosure designers in meeting the NEMA and IP standards.
Thank you, Dan. We have another one here. It's about air filtration versus liquid cooling. Someone's wondering, is there a general rule or guideline that applies to the power level of inverters and when air filter solutions might become less than desirable? The audience member said that they noticed that somewhere around 1 megawatt, there's a shift to liquid cooling for maintaining a more constant delta T at the IGBT junction. So they're wondering if an air filter would be preferred, but they've had experience with these trade-offs and would prefer the air filtration versus liquid cooling. So I know that's a little lengthy, but I hope that makes sense.
Yes, I'm not familiar with the wattage threshold, the 1 megawatt, for instance, but we are aware that liquid cooling does come into play and does help with, providing thermal management for larger, more thermally challenging systems. I guess there was a question in there that pertained to the undesirability of forced air cooling, and I would answer that with yes, it is inconvenient to have fans and blowers and filters in systems because fans fail and filters get dirty and they need attention. They are, in many cases, a necessary component of thermal management, and therefore forced air cooling with filtration is used very popularly in all types of systems. When liquid cooling is introduced, it can be a replacement for forced air cooling and fresh air systems. We see many outdoor enclosures and shelters that are cooled by closed systems, closed air-to-air heat exchangers that do not require filtration, but at the same time, we also see a combination of liquid cooling and forced air cooling in a single system, which includes dust filtration to protect heat sinks and other thermal management liquid cooling components that need to have cooling air brought across them to allow the system to be thermally competent. So I hope that addresses the question. I realize I didn't cover the exact times when liquid cooling versus forced air is most appropriate, but that's getting a little bit out of my expertise.
I think that's a great answer, Dan. I appreciate that. Thank you. Good question. We have another one here. You mentioned quadrifoam media. Could you explain this in more detail and why it's more effective than traditional filtration media for solar applications?
Quadrifoam is an open cell polyurethane foam air filter media, and it is dual configurable, meaning we can configure the porosity or the density of the pore structure to make it less restrictive or more restrictive depending on the custom airflow requirements of the application. It can also be configured at the same time in different thicknesses. So the combination of porosity or density and thickness of the foam media allows you to configure a custom filter that meets the customer airflow requirements precisely. The number one feature of quadrifoam is its flame retardancy. We mentioned UL 94 flame ratings that are required for many of the industrial equipment and power gen end item assembly standards that need to be met out there, and these end item equipment standards typically will refer to require UL component plastic ratings to make sure that everything going into these devices and these enclosures is fully flame retardant. So Quadrafoam, while it's very versatile for configuring custom filters to meet the specific requirements of the application, it's also rated UL flame safety to the highest rating that's available from UL.
Great, Dan. Another question here. Is it popular or possible to retrofit existing equipment deployed in harsh environments with air filters to provide equipment protection?
That's a very good question, and that's a very popular question we get from field engineers, field service technicians who have equipment deployed in their power gen facilities that arrives from OEM manufacturers without any filtration option included with it. So sometimes equipment is designed for indoor use or mild environmental conditions, and when you put them into a solar farm or a power gen facility, which tends to be much harsher environments, then after a time in the field, the requirement for filtration creates itself. So we get many requests from field techs, looking for retrofit opportunities to improve the equipment protection qualities of their systems, and we regularly come up with quick retrofit designs to keep these systems up and running.
All right, I think we have about time for one more here. So, Dan, are there risks associated with form, fit, or function cleanable air filter replacements to displace OEM provided disposable air filters?
Yes, there are. I think the risk is deviating or straying from the custom specifications that were required during the design of the original equipment. And we talked about Quadrafoam being specifically configured for the individual application for airflow and dust protection. And what we see regularly with aftermarket replacement applications is field techs will purchase a filter off the shelf, or find a filter that's readily available and not required to be OEM approved, and they tend to fail on the side of too restrictive and too much pressure drop. So we'll get complaints from the field that filters are blocking off all the airflow, and it's because they're not OEM approved and the original design specifications were not considered with the replacement. So as we emphasized in the presentation, be sure to use only OEM approved air filters, because the risks of equipment failure definitely multiply when you stray from OEM approved.
Great, Dan, thanks. All right, well, I think that's all we have time for today, but I sure learned a lot, and I hope you did too. If I didn't get to your questions, or if you have additional ones, feel free to contact Dan on your own. His information is right up on the screen there. And again, this webinar will be emailed to all registrants, so you can view it again at your convenience. I'd like to thank Dan one more time for being here to share his excellent expertise with us. We really appreciate it, Dan. And also thanks to everyone in our audience for listening and asking such great questions. Your input makes for great discussion. So I hope you enjoyed our presentation, and we invite you to join us for more Solar Power World webinars. Thanks, everyone.